Hi everyone, let's review how to do the gram formula mass of a compound. First, let's think about what this phrase is really saying. First is asking you to do a mass. The mass of what? The mass of a formula. Now, what formula could they be talking about? Well, in chemistry, we use a lot of chemical formulas. For instance, the chemical formula for water is H2O. It tells you how many atoms of each element is actually involved in the compound that is water. 2 hydrogens and 1 oxygen in this case. Now, we're going to do the mass of the formula, and that mass we're going to express it in grams. Okay, that doesn't sound too bad. Now let's see. So we decided that water has H's and O's, and at this point we know that hydrogen and oxygen have a particular mass. You look it up on the periodic table and you'll realize that hydrogen has a mass of 1 and oxygen has a mass of 16, and I am going to round here. Okay, I know it's 15.99 something, but we're just going to round up so that we can make our life a little bit easier. So that is the mass for each one of these atoms. Now the formula states that this water, or any water for that matter, has 2 hydrogens. You see how that number actually speaks to the element that is right before it, not the one that's after. So it's actually talking about 2 hydrogens. So then this mass of hydrogen, I have to multiply it by 2. The mass of oxygen, I basically have to leave it alone or multiply it by 1 just to make it really obvious. So here I have 2, here I have 16, and if I add all of that up, I would have 18. 18 what? 18 grams, and we decided that that is the mass of a mole of water molecules. If I had 6.022 times 10 to the 23rd power particles, like molecules of water, that many, which is a huge amount, a mole, they would actually weigh 18 grams. All right, let's do another one that has parentheses and more numbers. Let's see how we can walk ourselves out of that. First, again, I like to make a list of all the different elements that I see. So I'm going to start here. I see nitrogen. Following that, I see hydrogen. I keep looking around. I see sulfur. And finally, I see oxygen. So these are the 4 elements that are involved in this formula. Now, I need to figure out what are the masses of those elements. I will look at my periodic table and I will notice that nitrogen, rounding it up, has a mass of 14. Hydrogen has a mass of 1. Sulfur has a mass of, what? You said it. 32. And oxygen has a mass of 16. Alright, so if I had only one of each, I would just add that up. But that is not the case. I actually have a different ratio. Now let's see how many of each one of these atoms do we have. First of all, I have to notice that I have a 2 right here that is outside of a parenthesis. That means pretty much just like in algebra, that is going to actually multiply everything that's inside the parenthesis. So that means I need double the amount of hydrogen, and I also have double the amount of nitrogen. So then that means that I have 2 nitrogens. So I'm going to multiply the 14 by 2. That means that I have double the amount of hydrogens, but I have 4 hydrogens. You see this 4 right here? That was for the hydrogen. So if I had 4 and I have double of that, I actually have 8 altogether. I jump over now. That pretty much finishes up the parentheses. I get to the sulfur. It doesn't really have a number, so it's only times 1. And then I get to the oxygen, and then we have that 4 is going to be the amount of oxygens that we have, so that has to be times 4. Then I can go ahead and do my math. That is going to have to be 28, 8, 32, and 64, right? And so that's the mass of all the different elements, and how many do we have of each? But that's not what we want. We want to add it all up because we want the mass of the whole formula. This is when I grab my calculator, because there's nothing worse than doing all this work and then making a little mistake you know, mentally not really adding it up right. So I really encourage you to grab a calculator and always verify your work that way. Okay, so you should actually pause the video and do it before I get to show it. And I think I made a mistake, actually. I'm going to do it again. And that is going to be 132. What? Because without units, we don't know what we're talking about. So this is going to be grams, because hello, that's what it says over here. This is always in grams. Grams. So apparently if I have 132 grams of ammonium sulfate, which is this compound right here, I actually have 1 whole mole of that compound. Okay, I'll see you in class.